Welcome back to Wickerson Studios. Michael Wickerson here. We're moving on to the sixth sixth video of the first script of AI Copilot into AI Stable Diffusion. But what I'm doing is I'm going through, and of course I'm building getting you acclimated and starting with hops and the Grasshopper. But then I'm jumping into Numpy basics. What I'm doing with that is I'm showing you how to script something like this to begin with, like an one-dimensional array, two-dimensional arrays, and then n-dimensional arrays. But I am providing some data visualization as we go. And instead of building this type of stuff before, which was fairly top-down, geometric over here, I thought it might be interesting to deal in 3 dimensions and start building some models. And I've chosen the parallel, which you can, over here in set view, you can set your isometric and set your views and name views as well. But I'm just choosing, I don't know, southeast or northeast. I can't remember which one I collected. But I baked some of these geometries too. And all of these geometries, you see there's a couple of flubs over here, coincident forms. Over here, there might be an opening. But that geometry that's there, and I'm going to leave this stuff, is coming from the visualization of a n-dimensional array, which happens to be a 2D array of 3 lists. And those 3 lists provide us some good tree structure. And the tree structure can be brought in, and sometimes I use my counts to provide me some information. I didn't use them in here, but the data visualization was I basically, let's grab these guys and put them to visibility hide. What I did was I jumped in here and I decided with a point grid. And that point grid is driven by the NumPy array, which is driven by controlling this gene pool. And you can think about the curves that you're building here. It does work best on this script if I keep it so it's ascending order and things don't dive below another one. So leave it around there. I'll just fudge this and make another one here, and you'll see how it has an effect. If I just pull this one down farther this way, it's going to make for a different kind of piece, and then step over here pretty fast. But that's another geometry that's created a set of points, and there they are, updated. Those points are going to move into a really nice structure upward, and because they're maintaining their incredible data tree from arrays, list of lists, I can throw those through a nice little loft. And from that, I just do a little bit of acrobatics of taking this apart, analyzing it. I threw a huge plane in over here just to project to. It's not the most graceful way of doing it, but it does the trick. And I project over to it. So I basically grab this geometry and project it over to this geometry with a shift, and where it connects is right there. And now I can deal with that. As it dives in here, I can grab my curves, this curve and this curve, which you can't see there, and I can bring those together into this loft, this into this loft, and this into this loft. And then with all those other geometries that were there, I can bring them all together, and there's this interesting thing that happens here. Let me just go back. Interesting that happens here. It closes it all up, but it leaves open a little bit of a doorway, which I think is kind of interesting. So when we go in here, cancel, I just hit something there. I hate working this when there's a group around it. So that's all done. There's your brep, and you can actually take that little brep, which is this closed structure, top, bottom, side, beautiful piece of solid architecture with this strange little doorway in here. And I really like manufacturing these little guys. So this one I'm just going to take to a bake. And you'll see that it jumps in. You've got some really nice geometry. And I'm just going to pull that one aside over here because I'm not going to need it. And then I'm going to take this off and I'm going to pull back up my other geometries that were there. So that is a nice little script that with a little bit of understanding of Grasshopper afterwards, but a firm understanding of arrays, you're able to build some really nice geometry and tight little structures. Now, of course, it's not engineered to be something sensible. It's creative. I know I get a lot of complaints and people that are disinterested when I do things like that, when it's not like, optimized. But think about this as a volume. If you closed it, you can catch your errors here from your number data. And what's nice about the gene pool is if you get something you kind of like, so if I take this one off, which was there before, if I remove that one, I've got my ghosted form, which is there. And you've got something you kind of like here, and you just want to alter it a little bit. That's what I think the power of the gene pool is you can just go into here and you can change it 10%. and you see it's dipping and diving a bit, so I might want to correct that. And if I really like what I'm doing, I just want to alter 1%. You see that that's just playing with it, and I've got a whole other form of a very similar structure. Very strange building. This one I don't really like so much because it's got those problems with it, but I can leave this one in there and get ready to do a little more with it. So that's it. It's a very powerful numerical control, Numpy, if you want to use it. And then you can use all your old fancy, 6 to 12 node scripts, maybe 24 node scripts to pull together a interesting model that is completely parametric and computational, but driven by the old, let me see where that went, Visual Studio Code, which is right here. And I'm running that by creating and running in a hop server. Of course, if you want it active, you have to be running it. But I can run on other servers. You can put it up on the cloud, you put it up on GitHub, let other people have access to it, and that's what I'm hoping will happen. So that's it. The visuals are getting to be pretty fun. If I pop up everything, you see that we start to have this ghosted view of what Grasshopper is. This clumsy surface is a little distracting for me, but I don't mind slowing down. What I'd like to do is get a model working in here first and then tuck it in maybe into the node if you want. But like I say again and again, get in here to the NumPy, take off the cache memory, the cache server, only output your array as lists, entwine them back together and have total control over what would normally be something like a data tree that's getting away from you. I understand these are just numbers, but you can also control those numbers back in with all the operations that arrays can have at a lightning speed compared to what you normally would do with lists and for loops and everything else with other programs. So tapping into that NumPy library seems to be the real key. And I like the visuals that I have going on, and I think it's pretty cool. So there they are to start. There are my models, and I'm going to leave it at that, and then I'm going to go back into my NumPy. I'm going to take off my solver. I'm going to follow down here, and we're already looking at scaling a n-dimensional array, which is what we're going to do next. So that is it. We are going to stop recording.